We'll start with a welcome from our school director, Dr. Adil.
Thank you very much, Gord. Welcome, everyone. It's a real pleasure to have you all join us tonight. And I presume you're joining us from different parts of the world. So it might be morning or afternoon where you are. So, very warm welcome to all of you. Here in Canada, it's quite customary to start with an acknowledgement that the land and the territories on which we operate as SFU are belong to Indigenous communities, and they are not ceded by those communities to anyone. So we are quite cognizant of the fact that we are operating on these territories of a number of First Nations. Here in SFU Surrey campus, where our school operates, that includes Semiahmoo, Ketsi, Coquitlam, Kwantlen, Kikite, and Tsawwassen First Nations. And this is something that we take quite seriously in our work and in our academics, that we try to incorporate this knowledge of the Indigenous communities and their knowledge base into our work. So it's a great pleasure to have you all. You're going to hear quite a bit today about the exciting program that we have embarked upon. It opens a number of opportunities for engaging with the industry. You'll hear a bit more about that in our presentation. And it also exposes you to multiple disciplines. So we have engagement with political science and with resource and environmental management, with the School of Business. So many facets of this program are really very interesting. We're excited to get this program started. And we are delighted that you are considering being a part of it. I hope that at the end of the session, you have made a commitment to join us, and we look forward to welcoming you this fall. So with that, those few words, I'll pass the floor back to Gord.
Great. Thank you very much, Adil. So yes, I'd like to start with an introduction where we introduce your co-host for today. So we've got Dr. Ignacio Zibrigan, Dr. Vahid Hosseini, Shannon He, and myself, Dr. Gordon McCarrick-Cowan. We're all members of the School of Sustainable Energy Engineering here in Simon Fraser University. And one thing we often think about when we start these conversations is really what is sustainable energy engineering? Because it's not a traditional discipline of engineering. It's not a mechanical, it's not electrical engineering. And so we've been working on this over the past 5 years to really try and define what is sustainable energy engineering. And really what it comes down to is it's looking at ways to develop and implement ways to harvest, store, transmit, and use energy that meet our current needs and that don't impede the future generations from meeting their own needs. And so we span everything within the school from renewable power generation to clean transportation to um, land use, food production, water use, energy use in buildings. We cover a wide range of different topics, but all within the same specialization area, which is really a focus on energy and the interaction between energy and the environment. So the school is a full-scale department within the Faculty of Applied Sciences here at Simon Fraser University. We opened about bit over 5 years ago now in September 2019. We have a brand new building. There's a nice picture there of the new building in Surrey. So Surrey is the fastest growing city in British Columbia and located about a 40-minute transit ride away from downtown Vancouver and about 25-minute drive from SFU's main campus in Burnaby. We currently have something on the order of 250 undergraduate students and about 50 graduate students who are focused in our research streams, which is our Masters of Applied Sciences and PhD programs. And of course, the undergraduates are doing a bachelor's in applied sciences it's about a 4 to 5 year program and typically takes students coming out of high school, that sort of thing. As we've been looking at this program, our school, we realize there's a gap. We've got a really strong undergraduate program. We've got a really strong research-based graduate level program, but there's a gap in the middle there, which is for a taught graduate program. So this is our Masters of Engineering program. is designed, and we'll hear more from Ignacio and from Vahid later on about this, but it's designed to be a relatively compact program that will take people and take students who have an undergraduate degree already and get to them to the point of having a good solid base in sustainable energy engineering that they can then move on and grow their career from there. So just a few little simple photos of some of the different facilities we have available. We have fairly well-equipped labs that are in thermodynamics, fluid mechanics, material sciences, electrical systems, power systems engineering, and all the ancillary support you would expect. So CNC and additive manufacturing capabilities, lots of instrumentation and controls work, all that sort of thing. And we also have access to the wider infrastructure across SFU. So this includes things like our 4D labs facilities, which are advanced materials processing and advanced materials measurement technologies. And of course, all the typical computer labs, collaborative project spaces, everything you would expect to see in a modern university setting. So who are we? These are the our current 18 faculty members in the school, and we span a wide range of focus areas from urban and built environment through to land use, land energy, water use, the social and environmental impacts of energy use and climate policy, vehicles, electrical power systems, air pollution. It covers a huge range. I'm sort of almost ticking off each one as we go. Batteries, energy storage, all sorts of different things. And we're not just sort of sitting in a bubble out here in SFU in beautiful Surrey, British Columbia. We have a wide range of collaborations across the world. So Europe, Asia, in the United States, down into South America. We really do have international collaboration, and that's something that we really, really value. And especially because we have a fair number of international graduate students, we really see this as a nice synergy between the collaborations we have that we're developing and the students who are coming in and sort of studying with us. So with that, I will hand us over to Ignacio, who's going to give us a little bit more details about the program itself. Ignacio, I think you have control over the slides already.
All right. Thank you, Gordon. Hi, everybody. Thank you for joining the session. My name is Ignacio Galeano Zurbriggen. I'm an assistant professor at SFU School of Sustainable Energy Engineering, and I work mostly in power electronics, and I will be quite involved with this program, in particular teaching the Capstone project. But let's dive into what is this program. And I wanted to start by showing you some of what, in my opinion, are the highlights of the program. In this case, the program is brand new. This is the first time we're going to be offering it. It's quite unique, and hopefully I will be able to transmit or get across why we think this is quite a unique program. Part of it is that it combines engineering, policy, and economics aspects with environmental aspects as well. So it's it's technical, but also it has business components, it has environmental components. So it's pretty well rounded, and the idea is to create the next generation of leaders in sustainable energy engineering. The program is not only theoretical, although it does have a strong technical component. We do have a hands-on Capstone project and some hands-on applied components in projects at different stages in the program, which we're going to go over. And the program will be based at SFU Surrey campus, which is the newest engineering building Simon Fraser University has, state-of-the-art facilities. So that's also, in my opinion, one of the highlights of the program. And not less important is that the program is quite affordable. It's a full-time program with regular fees, and Shannon is going to elaborate a little bit more on that. But I think that is also, an important aspect of it. It's by no means prohibitive from a cost perspective. So I think that you will find that interesting as well. Let's dive into some other aspects of the program. As I mentioned before, this is not only a technical program. It does have components that will teach you leadership and other skills such as teamwork, creative thinking, communications, ethics and responsibility, business, policy understanding. And so, as I said, well-rounded program, and the idea is to get you well equipped to be able to work in different areas in sustainable energy engineering that you may find attractive. You might want to steer more into the policy aspects with a strong technical background, or you might just want to pursue a technical engineering career. And this program will be helpful no matter what path you want to follow, as long as it is within the sustainable energy engineering business. Let's go into what the program is and what it looks like. So it's a 16-month program. It has 4 terms of 4 months each. And during those 4 terms, we are going to cover core courses that are basically here in the first 2 terms, C771 and C772. We're going to be talking more in detail about each one of the courses in the next few slides, but those are the core courses. Then you will have technical electives that are going to be in the 2nd and 3rd semester, and then real-world projects embedded into different courses and in the Capstone project by the end of the program. Let me just break it down a little bit more graphically, so it's hopefully more understandable. In green here, we see the engineering core courses, as I said, C771 and C772. Those are going to build somewhat the foundation and some applications of the program. Then we have environmental, policy, and business courses that we have here shown in blue, 773, 790, and 791. Those 2 are done in parallel in the first 4-month term. And then we have C770 also as part of the environment, policy, and business courses. Then we have 2 technical elective courses shown here in yellow, and the Capstone course shown in red over the last 2 terms of the program. Let's go into each one of these courses and see, in more detail what you will be covering or what we will be covering in them. Oh, by the way, this QR code right here, it's a link to the program itself. So if you are interested, or you can find it navigating our website as well. That is the entire program, and it has links to all of the different courses as well. Let's continue and dive into each one of these courses to see what we will be covering in there. So as I said before, the 2 green courses here, the 2 technical courses, core courses that we have are foundationally, the first one, C771, Sustainable Energy Systems 1. And this one will build foundations around critical engineering principles, will overview that are relevant, obviously, to sustainable energy engineering. We will overview electrical power systems, material sciences, and thermodynamics, describe different energy systems, modes of energy conversion, transfer, and storage, and all will be covered at a system level viewpoint. This is, as I said, quite foundational and will build a strong basis for us to continue working towards applications and towards those hands-on components that we want you to experience as well. C772 will be steering in that direction and taking us into that applied path. So in this one, we will be applying engineering principles to the evaluation of energy systems. So we will dive into more detail into electrical power generation, electrical energy distribution and smart grids, vehicle transportation systems, building energy and built environments, and current and emerging technologies as well. As I said, this is our second core course that will take us closer to these applications. And then you will have also 2 technical elective courses from that you will be able to choose from the available pool of courses, which is, being the School of Sustainable Energy Engineering. There's a great pool of courses. You will have to select at least 2 of those, and those include, batteries and energy storage, carbon capture, energy systems modeling, smart grids, air pollution and control, vehicle and propulsion technologies, high performance buildings, among others that we are continuously, creating. So this will be your chance to give the program your own flavor, and this, hopefully these 2 courses will let you tailor the program to something more applicable for what you want to do after completing the program. Then if we move on, we have the environmental policy and business courses, also quite an important aspect of the program. As I mentioned, we will not only cover technical aspects, but also policy, business, and to build a nice, well-rounded professional, which are the future of this sustainable energy engineering business. C770 will dive into the water, energy, and food nexus. It will look into integrated policy and engineering solutions that simultaneously address the nexus between the 3 different sectors. It will include innovative technologies and engineering challenges, policy. There's a strong policy component as well, and it will include some real-world problems, which, as I said, it's kind of an intention in this program as well. The 773 is sustainable energy policy. Will draw into sustainable energy development and climate change, energy systems from a historical perspective, what brought us where we are now. And that it's important to know that history to see how we got where we are. What are the policy frameworks in economical, political, and regulatory terms that we have today? And then this course will have you writing some policy briefs and memos from also quite an applied standpoint. So you will actually get to practice what that means. And the business courses, as I mentioned before, these 2 will be done in parallel over the first term of the program. They are done, well, not in parallel exactly, they are half a term. So there's 2 months for 790 and 2 months for 791. In these courses, the courses are lab to market and opportunity identification and assessment. It's for those of you that are interested in the business components and maybe entrepreneurship, creating startups. So it will draw onto some of those aspects as well. And for those of you that are mostly focused on technical jobs or technical opportunities after graduation, it will give you a nice perspective of what the business environment actually looks like in this sector. So that is something also that we really, really value about this program. I'm trying to go very quickly, but please feel free if you have any questions about any of the courses or anything about the program, note them down and we can come back to it in the Q&A section. Let's continue to the course that I will be teaching in this program, the Capstone project. This is, as I mentioned before, a course that will take place in the last 2 terms of the program. In this course, students will work in teams to tackle a project that will be defined by an industry partner or a research partner that we have. And so we will define these projects. They will be real world projects. So you will work with your teams to integrate all of the learning that you have acquired through the program to an applied problem, and hopefully come up with creative solutions as well. It will have quite a bit of a communications component as well. You will need to navigate the communications with your customer, with your team members, to deliver presentations, prepare reports. So it's going to be quite an interesting course with a strong applied component. This is all of the program highlights or the overview of the program, but we also want to draw onto what's next for you and what you can do with this degree. I will be taking care of this section as well, so please bear with me for a few more minutes. So the idea of this program, as I said before, it's to build experience so you can undertake a career in sustainable energy, in the sustainable energy sector. As we said before, this program is quite comprehensive. So the idea is that no matter what sector you want to go in, you will have some of the tools that you will need. As some of the examples, graduates from our school have gone on to working on building sciences consulting, greenhouse gases monitoring and reporting, hydrogen fueling system deployment, fuel cell development, utility planning and system design. I should add there battery energy systems. I work in power electronics myself, and that's an area that will be quite relevant as well. This could be also a nice path to transition into master's or PhD studies. We will build some of those foundations, and ideally, the program itself could be useful as well for a transition into research studies. As a quick overview of, as Gordon mentioned before, we do not work in isolation. We are well connected internationally with different institutions, including universities and companies, but also with local. Some of these companies are local, some of them are Canadian-wide, and some of them are international as well. But this is a list of the current collaborators that people professors in our departments have, or that we have been collaborating with. So you will find a whole lot of very, very important companies in the sustainable energy engineering sector. We won't go over each partner in particular, but it's just to give you a quick overview of the partners we do have. And then, of course, after you graduate, it's the transition into what you will do next. It's not going to be, we will work with you to make it as straightforward as we can. The university has a lot of resources. There's, let's say, if you're interested in building a startup or going to the entrepreneurship way, there's an pretty interesting innovation ecosystem at the university. We will host career festivals that will be open to all SFU students and alumni once you have graduated. We have a career advising at SFU, in which the professionals there will give you guidance on how to build or how to plan the next steps of your career. And that CGRAD is a nice graduate student conference that we host every year for research-based graduate students. We have a nice picture right here on the right. So these are some examples of the resources that we have. There's 2 links down there to the innovation ecosystems and to career advising. This is just to tell you, I know it's quick, but it's to show you, you will not be alone. You will be supported in your transition to the next steps of your career. So with that, I think this is it pretty much from me, and I'm happy to pass it on to Shannon to draw on to very important MEng admission aspects.
All right, thank you so much for this detailed walkthrough of the program itself. Now that everyone's excited and looking forward to questions on how to be part of the program, I am here to walk you through what you need to do to get admitted to the program. My name is Shannon. I'm the school manager. I am here to show you the next steps. So for admissions requirements for the program, 1 second. Oh, yeah. So this is a graduate level study. So what that means is, in order to be admitted to the Master of Engineering program, you need to meet some of the criteria for our selection review committee to be confident you have what it takes to be successful in the program. how do we do this? Is we need to see your previous academic study. We want to see that you have completed a previous bachelor's degree, either in engineering or related science field. We want to know that how did you do in your previous study? That is, we want to see an equivalent to SFU's B average. For students at SFU, we're looking for a CGPA of 3.0 out of a grading scale of 4.33. If you are from a different institution that use a different grading scale or from an international institution, we do do the conversion for you. But if you want to take a look of the international equivalencies, that is available through the QR code. And in addition to your academic performance, our committee will also want to know you as a person, as a candidate, what draws you to this program itself. We have spent time like in this info session, we have put information on our website to share with you what this program is about, why you should be interested in it. And now it's your turn to show us what makes you a good applicant to our program. And how do we determine that is through a letter of intent. So based on this, we want to know what interests like what is your future academic plan or career long-term prospect. And we want to see your resume and CV and to make connections to what you want to do in the future. And we also want to hear from at least 2 referees who have seen you in an academic setting or worked closely with you, who can provide some context to your work ethics, your interest in the field. And if you have completed your previous study in a non-English speaking country, we want to also see your demonstrating your English language proficiency. So please scan the QR code that will take you into information that shows you requirements for IELTS, TOEFL. That's roughly the equivalent to IELTS academic 6.5 to it's very standard requirement across board. And next, once you have this information in mind, how you can prepare for the next step is go to our website on that link that will take you to the applications page. So we have 3 steps that you need to work through to complete the application process. The first step is to complete the application form itself that asks very general information. Who are you? Your name, your address, your nationality, your academic background, where did you go to study, and identify this program as your point of interest. It should not take too long, but do set aside about 30 to 45 minutes. And then once you hit submit, it will take you to the application payment page. If the application payment is not determined by your citizenship, if your study are all from Canadian institutions, your application fee will be $110. If part of your academic study is done outside of Canada, the application fee is $150. Once the payment is complete, you will be taken to the application checklist. That's where you can upload information like your transcript, your letter of intent, your CV, resume, and also provide contact information for your references or for your referees. It will trigger a link to your referees to provide the reference letter on your behalf. Our official application deadline is February 28th. But for anyone applying from outside of Canada, if you know you need to apply for a study permit, I strongly recommend you start the process as soon as possible and let your reference know to submit your references as early as possible, because your application will not be reviewed until all information is received from you and your referees. All right. Last but not least, the cost of the program. So one good news, or things that's most notable about this program, is the program is charged a regular tuition. That means it is the same cost, regardless if you are domestic or international. And the information is shown on the page linked there. The estimated cost based on the current academic year is about $2,520 per term. The program will last, the completion of the program will take 4 terms. That gives you roughly around just over $10,000 for the entire program. Of course, there is additional, like the fee is subject to change. Please check our website linked above for the latest fee for the year you are starting. In addition, I would highly recommend you use the budget calculator to calculate additional costs like accommodation, food, to set aside enough financial support for yourself. All right. With that, I will hand back to
Thank
Gordon.
Thank you very much, Shannon and Ignacio, for your excellent overview. I think we're just about at the point where we can start answering questions. Just before that, I just wanted to close off by just saying we are, as a faculty complement, we are really excited about what this program offers. We think that it's going to be a real game changer for people who are students who are coming out of traditional engineering programs and haven't quite got that sort of niche into sustainable energy engineering that maybe was what they got into engineering in the first place for. And I think we've really got a really exciting program. We've got some really interesting integration there with the different courses like C77. The policy course is actually going to be co-taught with political science. So we're going to have these interfaces and interactions that are going to really, really enrich the experience for the students who are in it. And we really believe that when you come out of this, you're going to really be positioned to become a leader in this clean tech, sustainable energy, clean tech space, which we know is going to be so important for the decades coming ahead. Okay, these are problems that are not easily solved. Solutions are possible, but not out there, not ready yet. And so our role is to really step in and help solve these challenges. So with that, I'm going to say thank you so much for your attention today. And what I'd like to do is open the floor to any questions.